Swayam Prabha. Digital India. Educated India.
Hi friends, now let us start the second part of the module incineration. In the first part we have discussed on the definition of incineration, mechanism of it, its advantage, disadvantages, its flow sheet for the incineration of solid waste, and in this part we will discuss on incinerators and their parts and types and the working, environmental impact and operational issues and divisions of real plant, and we will provide some case study. On the basis of the discussion we had in the first part of this module, we have come to know that particle size, time, temperature, turbulence play significant role for the combustion of solid waste. So, when we will be thinking about the design of reactors or incinerator, then obviously we have to keep in our mind about all those parameters, and considering all those facts, the people tried basically two types of incinerators. One is fixed bed and another is fluidized bed. Fixed bed means the material, here the solid waste or biomass, the bed will be fixed. So, this is your bed, fixed bed. This bed may shift from one place to other, but in fluidized bed there is no fixed bed. This bed, all particles are in fluidized phase, So, in this case obviously the size of the particles will be lesser than the size of the particles present in the fixed bed, and in fixed bed we are providing primary air, here also we are providing air. This air will help different methods like say drying, gasifications and combustion in a conjugative way, and will form the gas. Ash will be collected here. So, mode of heat transfer here is basically radiation. Here we need to provide some media, basically sand. So, the sand media is used here and it is heated up. That sand media and solid particles are in fluidized phase, and this hot sand media, sand particle transfer heats to the solid biomass or solid waste. So, mechanistically the transfer of heat is different in these two incinerators. So, efficiency is also different, temperature requirement is also different, and both the systems have some advantage and disadvantage. So, basically this fixed bed is suitable for any type of size, the size may be bigger, larger size. But now how the fixed bed incinerator works? Obviously we have to put the feed inside the incinerator. So, one feeding arrangement will be there, and we have to hold the material inside this combustion zone for say 30 to 45 minutes or say 60 minutes, like this. A larger time we have to put the material. So, we have to make certain arrangement so that the particles retain in the combustion zone for a longer time. That is why one grate is required. So, one grate is required. So, grate helps to retain the materials on the combustion zone and helps the contact of the materials with the primary air. Now, depending upon the nature of grates or the fixed beds are basically divided into two types, that is under feed strokers and grate firing. Under feed strokers means, see if we have one combustion zone. So, from the bottom part the material will come, it will goes up, and here with the hopper we have. So, here we are having hopper, the material is coming down and some screw arrangement is there, some screw arrangement is there. So, that screw arrangement is shifting this material from here to that way and it is pushing it inside this combustion zone. So, that is called underfeed strokes. So, underfeed stoker. So, underfeed stoker in this way. So, material comes from this and enters the combustion zone and then combusted and ash is collected from it. So, this is your underfeed stokers. So, feedstock here. So, feedstock comes through this like this and then it will go to your firebox. This is not very attractive and it has not very large applications, it is limited applications and it is used for only low ash content materials such as wood chips. This is relatively cheap and safe option for biomass combustion and easier to control than other technologies. Now, let us see the grate firings. In grate firing, wastes are spread evenly over the grates. Air is distributed uniformly throughout the bed and thus combustion is kept homogeneous and stable. It can use materials with high moisture and ash content as well as with varying particle size. So, that is the beauty of this process, that bigger particle size can also be used here easily, and different types of grates can be used, like say it can be fixed grates, moving grates, rotating grates, horizontal or inclined grate or water cooling grate, dumping grate and travelling grates. So, different types of grates can be used. Some of the important grates types are mentioned here, that is reciprocating grate. So, reciprocating grates means these grates have resemble stairs with alternating and fixed or moving. So, say this is on stairs, another is stairs is there. So, this is alternating. So, this is fixed, this is alternating. So, this can be moved, this part can move here and again this can go there. So, materials which is putting here that can carry forward. So, that is reciprocating movement, one stairs is fixed, another is having movable, and rocking grate system, that is pivoted or rocked grate type. Okay, this grate section produce an upward or downward motion advancing the waste down the grate, and roller grate. Roller grate is also, it is made of rollers. Okay, so, one roller is there say. So, this material, this is moving that way, another roller is moving that way. So, material is advancing. So, material will advance, the solid materials will advance with this, from this to this and this way it will be moving, that is roller grate. And rotary kiln. So, sometime rotary kilns are used and widely used in commercial scale, and that is as this is an inclined cylinder which rotates. So, inclined cylinders which rotates. So, once it is rotates on one end, we will put feed, it is having some inclination and it is rotating. So, material will move downwards, the material will move downward and from other end we will give firing. So, once initial firing is there, so high temperature is going on, so combustion taking place, gradually the combustion will goes on. So, gas will go upward and it will get escape from this. So, from this we will get gas and from here we will get ash. So, this is rotary kiln, and rotary kiln has wide applications for solid waste incineration. Here some example or some working of roller grates, reciprocating grates and reversed feed grates are shown. We have already discussed on it. Now, this is the rotary kiln, the operations. we have already discussed, and mechanism of waste burning and grates. We will see the grates provide sufficient time, grates hold the material in the combustion chamber and helps for the contact of oxygen and waste materials in the combustion chamber. That is very interesting. By changing the design of this grate section, we can monitor the quality of the gas. How it is? We can create different situations. In one situation, the air and solid waste travel parallelly in the combustion zone. In another case, the solid waste and the air travels in a counter flow mode, and in other cases center flow is also possible. So, here we are putting the solids. So, roller grate is used to bring it down, say. Now, we have to put oxygen, equally we are putting oxygen, and here entry, it is going this way, and this is the outlet of the gas. So, solid is coming here, we are putting here. So, solid is moving in this direction, air is also moving in this direction. So, parallel mode it is moving, and then when the combustion is being completed, the gas is going off. So, we can put here secondary air, we can add here primary air. So, secondary air we are putting there, or somewhere any place secondary air may be. So, this is the parallel flow of the solids and air in the combustion zone, particularly on the grate, that is parallel flow. In another case, we may have, this is our solid, solid is going in that way, we have rollers, we are putting oxygen here and here only, we are not putting oxygen there, and we are this is the situation. So, air is going that way, solid is coming that way. So, counter flow of solids and counter flow of oxygen. So, this is oxygen or air, this is solid, counter flow. So, it is going on, we are putting here secondary air. And another situation we can generate through center flow. So, center flow means we are putting oxygen or air, oxygen. So, solid is going in that way, solid is going that way. So, this will move, that will also move, and this will go in that way. So, here it is going. So, this is secondary air we are putting, this is primary air, this is solid. So, this is your center flow, this is your counter flow, and this is your parallel flow. Now, these three different designs will be having different characteristics and different influence on the properties of the produced gas. when we will prefer which one? Say the material is having low calorific value, that means carbon content is less. So, that will be requiring more heating. So, obviously, the parallel flow mode will help for the handling of those type of materials. But if we have some material, some solid waste having high heating value, that means more volatiles and more carbons. So, those will be not requiring that much of extensive heating. So, we can use say counter flow pattern and mixed and your center flow will be in between counter flow and parallel flow. Parallel, counter and center. Now, the parallel flow pyrolysis gases pass through hottest area providing high gas burned out. So, high gas burned out, and this is intermediate and low gas burned out. The parallel flow has disadvantage, the transfer of energy from main combustion area to ignition area is just by radiation. So, this is by radiation. And counter flow disadvantage is pyrolysis gases could bypass the hottest areas and may cause the gas burnout problem. And a center flow, that is flow and mixing pattern into the first path chamber are sensible to disturbances. So, these are the advantage and disadvantage of these different types of grates design which can be used for the fixed bed incinerator. Now, we will be discussing on fluidized bed incinerator. So, in fluidized bed incinerator, sand media is used. Sand media is fluidized along with the biomass or waste in the incinerator. Then heat is transferred from the solid hot sand to the solid particles. So, here time requirement is less, temperature is also relatively lesser. See, in this case which we need to put some sand, we have air, we need some feed also and sand. So, this is fluidized gas. So, particles are in fluidized phase. Now, the question is, a fixed bed can be converted to fluidized bed if we increase the air velocity. If we increase the air velocity, a fixed bed can be converted to fluidized bed. A fixed bed can be converted to fluidized bed, and minimum fluidization velocity for incipient fluidization that is able to separate the particles of the fixed bed enough from each other, so that their cohesion force is counteracted, and after increasing further air velocity, the fluidization will take place. Now, if we increase this air velocity further, so fluidization is taking place with bubble formations, further increase in air velocity, the solid waste as well as sand particles, part of it will be carried over. So, we will be getting two types of fluidized bed, one is bubbling fluidized bed, another circulating fluidized bed. So, circulating fluidized bed uses more air velocity, and in that case part of solids has to be recycled back. So, this is bubbling fluidized bed. So, in case of bubbling fluidized bed, we use intermediate velocity more than packed bed and lesser than circulating fluidized bed, and typical sand velocity for bubbling fluidized bed is 1 to 2.5 meter per second, 1 to 2.5 meter per second for bubbling fluidization. The bed normally has a temperature of 800 to 900 degree centigrade. It is very interesting that sand contains around 98% of the mixture, 98% of the mixture. So, these are the characteristics of the bubbling fluidized bed incinerator. So, here it is dumped, waste is dumped from the chute and air is passed from the bottom, it is fluidized. In case of circulating fluidized bed, air velocity is relatively more and part of sand and unburnt waste are recycled to the combustor after their separation from the flue gas in a cyclone. So, that will be separated in a cyclone and it will be recycled back, it will be recycled back to this. In this system, we have some riser part like this as shown here, and this is a closed system operation is required for this. This fluidized bed incinerator has some advantages. As such, it is suitable for high moisture fuel or low grade fuel. The typical operating temperature are lower than that of fixed bed, higher combustion efficiency and more suitable for large scale operations. So, these are the different types of incinerator which can be used. Now, whatever may be the type of incinerator, if we see the flow sheet, after incineration the hot gas is going for heat recovery. So, heat recovery is the second or third part of this. So, pre-treatment, incineration and heat recovery. So, heat recovery is the third part of this, an important part of this incineration process or flow sheets. Hot gas, when it comes in the boiler, we may get steam, we may get hot gas, gas turbine to electricity, steam to electricity, steam to any use or process it to preheating, etc. So, we have number of options to use this hot gas. Now, the recovery and overall efficiency of these alternative options are not same. As for example, if we use this hot gas only for heat applications, we can get 80% heat recovery. If we use steam only, then we can get 80% again recovery. We can get power only 35% recovery. So, this electricity and this heat which is available here, only 35% can be converted to electricity. Combined steam and power, we can produce both steam and power. In that case, we can get steam recovery 0 to 75% and power recovery 0 to 35% and overall efficiency is 35 to 75%. And if we use combined heat and power, then we can get 60 to 65% recovery for heat and 20 to 25% for power, and on overall efficiency is 85%. So, here maximum efficiency or overall efficiency is 85% when we can go for heat and power application. This is taken from some reference as given here. So, as per the flow sheet, after boiler we have your flue gas cleanup sections, NOx, mercury removal, dioxin removal and acid removal and particulate matter removals are required, and we will discuss these things in another chapter, another module. We will now discuss some operational problems which is experienced during the operation of these incinerators. Two important problems, one is your slugging. So, slugging will appear when the sodium and potassium oxides, the alkali metal oxides which are low melting are available in the waste in higher extent, and to quantify this problem slugging index has been developed by coal ministry, that is 0.1, that is defined by 0.1, that is as percent into percentage alkali in S. So, that is expressed in terms of megajoule per, this is expressed in terms of kg alkali per gigajoule, kg alkali per gigajoule. This is initially applied for the coal only, but now it is extended for the application for biomass and waste also. An index range 0 to 1.7 kg per gigajoule indicates that the material is not slugging at all. So, 0.17 to 0.34, 0.17 non slugging, 0.17 to 0.34 slugging, okay, probably, but if it is greater than 0.34 slugging. The slugging index of poplar and pine biomass are 0.11 and 0.009 kg alkali per gigajoule, that means these are not slugging. Another operating problem which arises, that is the fouling of the incinerator due to the formation of acids. So, if sulfur and nitrogen is present, so in that case nitric acid and sulfuric acid can be formed and that can affect the furnace. So, to reduce this effect, some materials like dolomite, kaolin, limestone, custom blends of alumina and magnesia can be used in fluidized bed. Different divisions of the parts of an incineration plant are waste, receipt and handling, then combustion system, then heat recovery, then air pollution control and the ash management, solid residue handling system. Here we will see some incineration plants planned or built in India. Narela, Delhi, there is 24 megawatt capacity, company is Ramki. Gazipur, Delhi, infrastructure leasing and financial services, there is 10 megawatt. Jabalpur, Madhya Pradesh, SL infrastructure 11 megawatt. Vallabhapuram, Tamil Nadu, SL infrastructure 5 megawatt. Surat, Gujarat, Rokem 12 megawatt and Jaharnagar, Hyderabad, Ramki 20 megawatt. This is one information on US incineration plant, that is Robbins Resource Recovery Facility, that handles MSW and reduces landfill waste volume by 95% and produces 50 megawatt electricity. So, Foster Wheeler circulatory fluidized bed and refuse derived fuel are used in this plant, and combustion temperature is 830 to 915 degree centigrade and high pressure steam is produced 6.2 megapascal at 443 degree centigrade, and that is produced in the circulatory fluidized bed boilers, is used to produce approximately 50 megawatt of electricity. So, up to this on this module. So, thank you very much for your patience.